Welcome back. This is Unit 4 for Chem 110, and this is where what we've been doing in the last units, measurements, sig figs, converting, making ionic compounds, making covalent compounds, all that lays the foundation for what I'm going to call the nexus of chemistry, which is taking those compounds that we made, putting them in chemical reactions, and then doing something with it. Quantities is code for math. Now, just so you know, to be able to do this material, there's a bunch of things that you're going to need. So you're going to need your solubility table, you're going to need a periodic table, you're going to need your ancillaries. Also, these notes were written a little bit for face-to-face, so sorry. Pop quizzes, you won't have pop quizzes if you're online. If you're face-to-face, you may have pop quizzes. But my point is there will be regular, what I'll call assessments to keep you moving forward. All right, so segment 1 is just a review of compounds, and this is in part why all kinds of compounds are included in this unit forward, okay? Some are ionic, some are covalent. We focused on simple binary molecular as an easy place to start. Some are acids, which have in beginning classes an H on the left-hand side. I gave you a list and so on and so forth. And you've learned that depending on the type, if it's ionic, you name it one way. If it's binary molecular, you name it another way. If it's an acid, for Chem 110, I gave you a list. Okay, so as a reminder, how do you recognize an ionic compound when you see it? Generally, but not always, it's a metal plus a non-metal. Okay, the exception is ammonium. Okay, ammonium is the singular polyatomic cation. That's not a metal. Okay, so remember, if I'm going to transfer electrons, so I'm going to use my little Lego man here. Okay, if I'm a metal, my little Lego man here that's decapitated, sorry, is going to lose this electron. So the metal will lose, and then the metal becomes a plus. And the non-metal picks up the electron, which means it gets a minus. Okay? Now, when you cannot transfer electrons, in other words, you don't have an electron to transfer, you don't have a metal, you have to share. And so that's how we recognize a covalent compound when we see it. Generally, but not always, no metals. Okay? So let's do a little reminder. Potassium oxide. Potassium is a metal. So this is going to be ionic. If it's ionic, you have to tell me the charge and the number of atoms that you have. Okay, so K plus O2 minus. If I have two minuses, I need two pluses. And I'm going to get that from two potassiums. So my formula is K2O. Okay, this is essential for moving forward because we cannot tally, we cannot do quantities if we don't know how much went into it. Okay, boron trifluoride is covalent or molecular. That means no ions, so boron is B, fluoride, trifluoride is 3. By the way, I assume you have a periodic table in front of you. If you don't, you should get one. Okay, so I'm going to set mine aside. Nitrogen dioxide, no metals, so that's also covalent. NO2, okay? And then last but not least, ammonium nitrate. Ammonium is our exception there. So ammonium is NH4 plus, nitrate is NO3 minus, so we get NH4NO3. Okay? So you guys were told to practice that over and over and over again. So if you haven't done it this way, you need to go back and do it the way I'm telling you to do it. Okay? Because otherwise you can't make these properly and you can't tally the number of elements that there are. Okay? All right, so this is what we want to do. We want to keep track of the atoms or elements, and I'm going to call that tallying, okay? T.A. Tyler might call it something else. If you're on a different website or a YouTube video, it might call it something else. I like to call it tallying, okay? Now, the other thing is once we count or tally our atoms, they're going to have mass, okay? So our little Lego man here, okay, if you can think of him as being an atom, he's going to have mass. And if I have two of them, let's see what I got in my visual aid arsenal here. Okay, well, I got two of them. They're going to have a different mass. And if I have, I'm looking for something different. Okay, if I have three different kinds of atoms, that's going to have a different mass. Okay, so that's what you have to be thinking about, and why I've yacked at you about making sure that you have your number of atoms properly